So over the years, we've definitely learned some things that we've incorporated into our practice and some other things that we've learned to stay away from. And so in our experience, we've really moved away from certain things. So what we found is that we've moved away from using things like recirc hoods in the kitchen. We like to, properly vent any of that, cooking particulates and all the gases that come from that out of the building, as opposed to using a recirc hood. And that's something that the Passive House gang was really into for a while, and we've kind of learned that it's better to get this stuff out of the building and take that penalty from having that hole in your envelope and some of the heat losses that come with it. So that's something we've learned. We've also learned to move away from using foam, petrochemical foam plastics above grade on our building. So things like closed cell spray foam, XPS foam, EPS foam. We've simply found that there's a better way to do it. We really think that if you're using foam above grade, it was a failure of your design team. Because if you design things correctly in the first place, there's really no need to be using that. So that's something that we've learned over the years. Other things we've learned, we've moved to a self-adhered or liquid applied WRB, so that's your weather resistant barrier. We found that these just perform better. They work really well for our air barrier. You don't have a lot of staples in this material. So we've just moved away from that over the years and found that we're getting better performance for that. Other little things would be things like plumbing recirc pumps or something like that. We can avoid that energy penalty of having a recirc pump that's, getting hot water pumped over to your faucet or your fixture so that when you turn it on, you get hot water right away. Instead, we found that through good design, if you locate your water heater and your plumbing runs so that there's home runs directly to these things in the shortest amount of time, you can actually get hot water to the furthest fixture very quickly without having to use one of these pumps that uses extra electricity. So some of this is a little bit in the weeds, but over the years, these are things that we have learned and just employed into our practice. Okay, we want to talk about how we're protecting the site. Any construction site that you're working in, you got large machines, you got excavators, you got people walking back and forth, you're disturbing the soils, and you really want to make sure that you're protecting the site itself. And so we want to make sure that we're getting all this erosion control material in place prior to starting any project, and then making sure that we're maintaining it throughout the project too. And so you can see here that, we've got a slope here, and so we've got some retainage happening here to keep the, as the machines roll up here and people are coming and going, keeping all of the soil in place and not allowing it to slough down into the sidewalk. And then we've also got these straw wattles, which are also keeping any muddy water or anything like that runoff getting filtered through that before it gets into the sidewalk and into the street. And the reason that's important is that, native fish like salmon are really affected by water siltification and turbidity and stuff like that. So as you take the aggregate of all the construction and things that are happening in a city, and you think about that rainwater, stormwater getting run off into the street, into the storm drains, and then into the rivers, it really siltifies the water and can really affect wildlife. And so what we're trying to do here is just keep all of the mud and silt and all that stuff in place, managing it on our site so that we don't get that running into our sewer drains and then eventually off into the river. Okay, so we're going to talk a little bit about some of the stormwater management that we have here. So all the water and rain that hits this building right here, we want to make sure that we're not sending it into the combined sewer system and off into the street. But the reason being is when we get large rainstorms here in Portland, Oregon, sometimes when you get all of that water that's hitting the buildings and that goes into our sewer system, it can overwhelm the system, and then sewage and stuff like that can get into the Willamette River, and we want to avoid that. So what we do is we manage all the stormwater here on site. So what we're looking at right here is just a simple downspout for the gutters. It'll go from the gutter back down to the downspout and collect into here. But this pipe is actually running to some dry wells that we've buried underground here that basically are a concrete ring that's filled full of gravel, and all the water gets hooked into that, and that slowly allows all that water to percolate into the soils and then just go down into the groundwater. So that way we're managing all the stormwater here on site and not sending it out into the street and adding to that potential of overwhelming the sewer systems and really affecting the rivers and the waterways around town. So why is Birdsmouth building, beyond code, and why do I think that other builders can easily move into this? Um, the reason we're doing this is because it's like a win-win-win situation, right? So you're saving energy by not combusting gas and using heat pumps and, saving energy through the envelope. And that's great, right? Because we need to save energy. We need to stop putting greenhouse gas emissions into the environment, all this stuff, avoid fracking and pipelines through native lands, all this kind of stuff. But the beauty of it is that you're actually getting a better product on top of it, right? So, I certainly, as Birdsmouth, we have our value set where we want to affect climate change through the built environment, but we also are craftsmen and designers and architects that want to build something that's better for our clients. And so by using a heat pump, heating and cooling system, building all electric, using a, heat pump, air to water, hot water heater, actually delivers a better product. These homes are more comfortable. The walls are 70 degrees, the floor is 70 degrees, the air temperature is 70 degrees. So you're not getting any of these like cooling feelings from your body losing its heat to the windows. And so you're getting just a better experience of the house. You're also getting much higher indoor air quality, right? So things like wildfire smoke, viruses, particulate matter is getting filtered out into these buildings, and they're not allowed to get into the building in the first place because of our continuous air barrier. So you're providing a space for our clients that not only saves energy, but is much more healthy, right? So that this is what people want in their houses, right? They want to be comfortable, they want to be healthy, and they want to be secure. I mean, these are the emotional reasons why people want to have a quality house. And zero energy building not only hits our values for that, but it's also what people want. And so we're able to bring these two things together in a way that is creative. There's a lot of problem solving. It's cutting edge. So there's new technologies. We're learning a lot. We're educating our staff. We're educating others. So it really fulfills our mission and provides something that's just a better product. You can use an induction range and it can cook as well or better than gas. You can have a heat pump hot water heater that's delivering hotter water than a typical hot water heater and is a smaller size, and you can deliver that inside your house. It's better. We're not combusting things and having nitrous dioxide, carbon monoxide, particulates brought into the space. So your lungs, it's cleaner for the people living there. So all of these things come together to create a really great scenario where we can deliver not only just really high quality buildings, but buildings that are addressing such a big, impactful part of climate change in our environment, all at the same time while being creative, fun, and interesting. So we really enjoy kind of bringing this all together. And, I really do think that there are certain components of this stuff that once you learn how to do this and you build it into the muscle memory of your staff, your builders, your architects, it's not any more difficult than what you were doing before. I mean, anything we do has been trained. You've put on Tyvek, that's what you've always done. It's easy. Now we're putting on a self-adhered membrane. Is it actually any more difficult? No, in fact, I'd argue it's maybe easier, but it's different. And so there's definitely a learning curve and there's some resistance to that. But I think there's a lot of things that other builders can do and incorporate into their practice, especially over time, that can get you building to this zero energy, zero carbon target without really having to do anything much more difficult. Our staff often talks about it's just building. We're building homes that are reaching regularly levels of airtightness that are less than passive house levels of airtightness. And it's not like they're working any harder, it's just building. And it did take a little bit to learn these things, and that's hopefully why through this course we can teach you some of these things. I can take some of these things that we have learned and some of our mistakes, pass them along to you so that you can incorporate this into your practice. And I really do think that most builders can reach these levels of performance without having to really break the bank or completely retrain things. I think it's just a different way of doing things. And once you get used to that, it all comes together. So here we're talking about our water heater strategy, and since we're in an ADU, we wanted to find something that was compact because we don't have a ton of space in these 800 square foot buildings. And so we also wanted to find something that was highly energy efficient. And on top of that, we wanted to make sure that we were delivering enough hot water for the occupants without running out of hot water. So we ended up using the Sandin water heater. It's an air to water heat pump. So what we're looking at here is only half of the hot water heater. What this is just a stainless steel tank. There's nothing else in there. And then we've got some plumbing penetrations that go through the exterior wall. And on the outside, we've got the compressor and condenser unit, which looks a lot like the outdoor unit of a mini split. And it's got a fan. And it's charged with CO2, so it's not using a refrigerant like one of the R1 refrigerants that are really bad for the ozone layer and the environment. It's a really nasty greenhouse gas, whereas here we're just using CO2 that's under high compression. And so all we do is we run a hot water line and a cold water line from this tank to the outdoor unit. And that outdoor unit takes the ambient heat from the air outside and compresses it and delivers that into those plumbing pipes and then delivers that hot water into this tank. And so it does it at a really high efficiency. So the rated efficiency of this on average is an energy factor of 2.65. So that means that it's getting 265% efficiency when compared to combustion. So the best gas-powered hot water heater you could get will only get about 97% efficiency, where this will get 265 on average. When it's a warm day outside and this thing's functioning at its best possible, it will get up to 500% efficiency. So 500% the efficiency of what you'd get from an on-demand gas or any type of gas unit. Now, the nice thing about this is that because it's not a combo unit, which is really common, it's a great unit, is they'll have the heat pump compressor on top of the tank, but it's gathering the ambient air from the inside of your building. And so it'll tend to dump a lot of cold air into the building. And so that can, go against your heating system and they'll compete. This particular one, since that is separated and we have that condenser outside, it doesn't dump any cold air into our space here. So we're able to be really warm and cozy in here and get that great efficiency. The Sandin actually holds the water temperature a little hotter than a typical hot water heater, so it's going to hold the water about 145 degrees. And so that means that we actually have to mix in some cold water from the exiting tank before it gets delivered to the fixture, otherwise it would be too hot. This has the net effect of this 40-gallon tank actually behaving like a much larger tank. So that way we can have a small unit with really hot water. We mix cold water to it to deliver to your shower, but that way it acts like it's a much bigger tank and we're not going to run out of hot water because we want to pay attention to that. That's that whole comfort thing for our clients. So really great and impressive unit. In this particular location, since we're in an ADU, we're really tight for space with 800 square feet. So we designed it from the very inception so that it can fit under our stairwell right here. And where I'm standing right here, there's crouching down rather, is where we're going to have the fridge, and the fridge will be flush to this here, and that'll cover the water heater back there. So you won't even realize where the water heater is. We do have a drain in back, and there is going to be a pan that this will sit in when it's finally installed, so that if this thing does overflow or there's an issue, it will drain into that pan and out the drain, so we're not going to flood the rest of the house, and keep that safe too. So really like these units, really special units, and they work great for these ADUs or for any really high performance home.